Hey guys, so first stop, how we start making some code, making some colors, you will want to go to this website. I will have the link in the description of this video. You just come here, make sure you got your right version. It should auto select your version, it should detect that, but if it doesn't, just make sure you've got your system selected so you could follow this on any of these systems here, anything from a tiny Raspberry Pi to if you have Linux or Mac, just go ahead and download. That will give you a zip file. You will just right click and extract that, assuming you've got something to open a zip file with, which you should. Then you double click the folders here, and you are going to run the processing.exe, leave the Java one alone. We don't like Java around these parts. So once it opens up, you are going to get some of these examples. I'm going to check this off, but I would leave it on first. It's really cool. You can click one of these and you have to run it. And from there, you can see some of the things you can do. I think this is one of the most impressive examples where you can see smooth running 3D animations like this. Um, if you can take a look, you can read all that code here. This probably doesn't mean a lot right now to you, um, but we're gonna go ahead and start. One thing to make sure of is go ahead and maximize it. Make sure it's selected on Python. It may select Java. You can use this with Java. That we're not covering that. It's gross. It's ugly. Leave it alone. Just don't. You will also, your line count here will probably small. Your font will be smaller. I would go to preferences. I'm doing 36 for the video. If it was just personally, I think 1824 is good. They had on 12, which is just, it's getting small for, since Python has uh, a lot shorter code. I prefer a bigger font size with it. That's just me personally. So first thing we're going to start with is making a statement. I think this is something a lot of tutorials gloss over, but a statement is pretty important in Java. So we're going to do the very first thing every single tutorial you'll ever see does, and say hello world. It's and this here is a statement. It tells the code to do a thing, one thing, and this will open up a small window here. Anytime you run code, you can run it and then run again. So I could run and make a window. It'll pop up another one down here, and it'll just keep doing that. So just be aware. I really wish, for some reason, the stop button seems to do very little to stop the onslaught of windows that will come. So just be aware. It's not a big deal. I sometimes when I'm making small changes, I will have 4 or 5 of these just keep stacking up. Don't worry about it. So with this statement, we'll come down here and say hello world. So whatever we put here will be said. So like I said, it's just one singular thing. And most programming or all programming languages have something that separates what these statements are. In Python, that is generally lines. So we could say another line here, and this be perfectly acceptable by Python. However, if we did this without putting it on a new line, we start getting ugly red text. We start having our intelligence questioned. I'm not happy about that. So, what's the problem? The problem is Python needs to be able to know, just the way dumb computers are. They need to be able to know, okay, what are we doing? Why are there two things put here together? Now we can fix this. Obviously, we can fix a new line. There will be times where you will be doing things that you don't want to have a million lines like this. So you have two options in Python, which is cool. You can also put a semicolon here. Think about it like a comma breaking up a sentence. So we have our sentence, we have our semicolon, lets us go on, and it will be happy with that. It will print this out. And every print statement automatically does a new line for us. In some languages, you have to do these yourself. Python is just very nice and friendly to us, and it allows this. And you can do this as much as you need. It's kind of weird that we're talking to ourselves. It's and this is another thing. You will have issues with some strings where because it needs this in order to tell where the letters that belong to this string versus where it belong to what we're trying to call as in functions, which I know is a lot of words I'm throwing at you, but you will run into situations where you have to escape characters like this in order to use them. And escaping means telling it, hey, I'm about to use this thing that's normally for a string, but it's cool. Or we're escaping. I don't know why they use that word. It should be like accepting or allowing, but we escape the fact that it normally means something else. But generally, you don't have to worry about that too much. So we've got these running. We've got a million windows spawn. So what's the deal? So what we're doing here, we are calling some part of function that knows to put text down here. But we were here to make colors and stuff. So first of all, it's not really helpful that this is this. I can barely click and drag it. So we need to tell Python that the size of our window needs to get bigger. So all we have to do is say, hey, make it 500 pixels by 500. And here we go. One thing I don't like is that we're doing this so we don't know which is which. It's 500 what by what. So let's try. We'll make it tall. Okay. So now we know the first one is how long it is, and the second one is how tall. So we're going to think about this as x and y. We're going back to linear algebra class. We've got our x that goes across and our y that goes up. And you will want to orient yourself whenever you're doing 2D or 3D things in any kind of code. You will want to orient where your x, y, and z are. So this is an easier system, just x across, y up. We will probably find some more tricky things when we start placing dots and rectangles and things places, but for right now, pretty easy. So now the question is, what do we do? This is just gray and ugly. Well, giving it a background is as easy as giving it a color. I am not sure if that does not take. Okay, so we don't have predefined colors. Well, we can use hexadecimal values for this, and I'll show you what that means in a second, but let's just make sure we can get a color up. So we pass it in as a string in the same way we passed in hello world, but we have to say this is a hexadecimal color value. And if you haven't seen these before, and you probably will want something to help you pick colors, you might not like this color, then you will want to go, and I have found if you just Google color picker that Google's built-in one here is pretty snazzy. It gives me about everything we need. We will maybe later want to switch to something like an RGB because this hex value is not giving us transparency. So if we wanted to make something see-through or not, we're kind of limited with that. We're not going to worry about that now. So simple hex values here are fine. So whenever you find a color you like say you like this orange, you can go ahead and use that. And one cool thing, and I think the book does a good job of this, and we're just going to go over it, is, well, this is just random whatever, right? Well, not quite. So if I wanted to make red, I know how to make red right now without looking up anything else. We just do two F's and all zeros. Well, how did I know that? The same way I know that if I make the first two red, or the first two F zeros, and now we go FF, this will be green. And then I can make blue by moving this over. So what this tells us is something interesting. And now, this might be less obvious if you haven't seen hexadecimal before. So real quick, your hexadecimal values. This is a cute little thing I googled up. Your hexadecimal values are, it's the same as, just ignore all the binary, but decimal, what we normally use, 0 through 15, and your hexadecimal, which is 0 through F, are that's equal to each other. So once you get to 10 in hexadecimal, we don't have 10. We do A, and it goes all the way to 15 for F. This is helpful for a computer because just how number systems work, it translates to binary easier to use hexadecimal. We're not really going to have to do any crazy stuff with binary, and hexadecimal normally isn't a thing, but it's just too handy for color values not to use. So just familiarize that. So if we don't want to make it fully red, we'll make it more readable for us. Say we don't like hex. Well, we can make it pretty red. It's darker, but this is pretty red. And, oh, come on. We can make it pretty green by doing the next two. So the first two numbers are telling what your red value is. So the higher those numbers are, the more red you will have. The higher the second two, the more green. So, if we bring in our color theory, we can, if we mix green and blue, my color theory is leaving me, we'll get this more blue-green color. But let's move over fully to F's to make it a bit more sensible. So we get more of a blue-green, maybe a teal. Don't stab me if I get your color wrong. But so we know if we do more red, no green, and some blue, we're getting closer to a purple. That is not the prettiest purple in my opinion. So let's go back to what we had, because I actually really liked that sort of deeper blue. I like that. That's a good base to put things on. So we know how to make backgrounds now, but what do we do with that? Well, we're going to make a rectangle. And this is the first time where to do something we actually need two statements. So we need to be able to say, let's build a rectangle and let's give it a color. So we're going to fill up this rectangle and we're going to give it another color value. What kind of color do we want to fill this rectangle? We're on this orange would be a nice contrast with blue anyways. So let's go ahead with that. And let's get rid of the extra hashtag. And so we're filling this rectangle with that color, but where is the rectangle? So we have to do similar to our size, how there was two numbers put in. We're going to do the same thing here, except we need more than two. We need 4 because this is a rectangle. It's got 4 arguments, right? That makes sense. Well, not really. All we need is length and width. So what's the deal? Why is there 4? Let's look. What if this was 50? Well, it's the same size, but it's moved. Well, it moved from 10 here. 10 was here, 50 was here. That might be like a tenth of the way across the screen, right? And it is 500 units. So what if we did 400? Would it be all the way? Yeah, it's about all the way over. So this is, the first value is where the rectangle is going on that x-axis. So it should be between 1 and 500. And I'm curious, I actually don't know. What if we have it kind of go outside? What if we did it the full 500? Well, we don't see it builds everything else fine. Well, what if we went right up against the line here? Okay, so you can draw things off screen. Nothing breaks. That's fine. And that might be handy for when we animate something. You might want to move something off of the screen. So that's legitimate. But, well, I want to be able to see it for now. And now I'm curious, so the first value is that. Is this maybe if we move this far down? Yeah. So these first two values are where does the first part of this rectangle start? And the second two is, since it was taller, that second value is probably the vertical. So you can kind of see a pattern here where, let's not make this a square, let's make this pretty big here. You can kind of see a pattern here where the first value when you have two things in processing, and this is, you have your x-axis, y-axis. Even when you're making a shape, even though it's not the actual window, it is still horizontal, vertical, horizontal, vertical. That's interesting. But what if we didn't want the rectangle to have a color? What if we wanted it to not? Well, we can do that. But what if we didn't know the color of the background? Well, we can just say, look, we don't fill it up. There we go. We have this. So, well, rectangles are good, so we can make a square, and we could. Um, Heck, it might be easier if you just always made squares, just put in the same two. There also is a square keyword here, and it only takes 3 things because these last 2 values will be the same. So actually, let's do this differently. This would be a good time to show you comments. So let's say that this is the same thing. It is 50. It starts at 50. It starts at 150, and then it's 50 wide and tall. However, we won't fill that, and then we will fill this with red. And you can see we've kind of overridden this rectangle. Well, that rectangle is probably still there. We didn't make it tall. You can see, or wide. You can see it's still there. So these, there's no laws here. If you want it to be, you just like, hey, it's easier for me to remember rectangle. I'm just going to do rectangles every. You can do that, or you can say, hey, I'm going to do square. I have to put one less thing in. I know it's a square. It's up to you. But it shows you there's more than one way to. Oh, I don't want to say that phrase. I like cats. There's more than one way to get the things done here. So from there, I'm sure there's other shapes, and I actually don't have any notes for what this would take, but well, we probably, going on what we have. Oh, that's wrong. So you can see. So the nice thing is they give us color code here when we have things wrong. So if I try to do this, it's gonna, that it probably will error out. Oh no, that's even worse. So that just doesn't run. It just hits here and it says I have no clue what you're talking about. Oh, and before one thing to do, we did not cover what I was going to, comments. So comments will make it. Let's get the triangles. I know you're excited for triangles. Just give me a second. It'll be okay. So let's say we had this here. Well, what if we just said, well, I want this to be here just so I have it. I don't want to delete it and retype it like I just did. That was a waste. So we can just do a comment. And now that rectangle's there. And then if we said, hey, you know what, actually I like the way that other looked better, we could comment these out. You just put a pound sign at the front, and then you go. But what if you had a huge list of things that you wanted to get rid of, and you didn't want to do this on every line? Well, what you can do is, if you put 3 quotation marks, or these, or this would be an apostrophe, 3 apostrophes, and then in the 3 apostrophes it does the same thing. So there's 2 ways to go about codes or comments. You can do things this way, or you can comment individual lines. And what's cool is you can also say, hey, now this goes to the end of the line and then stops, and the next line starts off without the comment. So this will still run. So you'll see comments like this very often. You'll sometimes see people put them at the top of code. Either's fine. It just depends on what shape you want to have your code in. And that's what I was trying to get to earlier with statements, is that there will be times where this is already getting top heavy, and stylistically for you it might be better to say, look, I'm going to put a red square here. And it works just the same. And some people will have a lot of opinions about styles and say, oh, well, the Pythonic ways it. Just block them out. Listen to whatever gets things done. Gets you pretty colors on your screen. We don't care about what they have to say right now. We can worry about that kind of silly, pedantic stuff later. Right now, we've got to figure out how to get a triangle to go with our square. And I actually don't know. I don't know what this takes, but going off earlier, well, the square it had to have an x and a y, so triangle has to have probably the same thing. We're going to move this out so that it's not hitting this. Well, it's got to have at least 3 things, right? And it's still got that fill from before, so maybe the fill is still set to red. Well, that wasn't quite it. So we've got to figure out what this is. And triangles have a lot more stuff to them. So in a square at least, because a square can double over. So we know that there's probably a way to place it horizontally, probably a way to vertically. This is probably fine, but what do we have to do here? Is it maybe each side? Maybe 3 of them? I'm not sure. So now we can start to look things up. And you know, you'll want to know. So you'll say, what if we just look up on the code? Well, this is the documentation here. Okay, well, this is a lot. They have examples here. So we had this right. We have our x coordinates, but we actually do it for each point. So we're actually going to have to place every single one. And now it starts to make sense because a triangle is just 3 points connected by lines, right? So let's try and figure out 3 places to put stuff. And I'm actually going to want to look at this first. So we've got our square here. Let's let's try and make it close to an equilateral triangle. Probably get it wrong, but we'll get it a little close. So this is 500 long, so let's put in the middle 250, and then that'd be 400. So the first point will be 250 by 400. We're going to consider that our first point to be our top point. So then we need to do one down here and one down here. Well, 500 doesn't really make a third easily, but we'll say we'll do something that's this close, 150. And you know, let's put the square's already up. Let's not crowd him. Let's go down a bit. And then we've got to do a third one. Well, if we're doing 150 and 250, 350 makes sense. And then we did 350 for this. We will do 450 for that. We will close out all our old windows. Well, that didn't work. What do we do wrong here? Maybe we have 2 of these on top of each other or something. Let's look. X coordinate of the second point. Let's look at theirs. 120, 300, 232, all the way to 80. XY, XY, XY. Let's go ahead and look at theirs versus ours. So let's see. Oop, we don't need that. Okay, so we're still filling with red, so we were right about that. We're doing that. But they did exactly what I was trying to do. So what did we get wrong? Well, these 2 values are kind of similar, but this is obviously where I made some kind of mistake. So let's move this down. Everything else looks sort of close. We'll just go with theirs. Well, that is a triangle. We get rid of theirs. It's a bit crazy, a triangle. So maybe we don't completely understand this yet. Maybe triangles are beyond our grasp. And let's close out all this silliness and rerun that. Oh, I copied theirs on the bottom. I just commented out the wrong one. Okay, so we can see we were probably doing almost a line triangle before with how we're doing it. Now we've got it moved over a lot more. So this 250 by 400, that would be this point. And we've done a point way over here at 150, only down to 80. So we were thinking this here was our top, but then we weren't actually doing the math down here. I was, or doing the, not really math, like this is hard math, but I was trying to draw out here in my head, and then I'm using values way up here. That's why we got more like a line. So let's just move this thing over. So this here, so the first point is 250, 400. Second point is 150, only to 80. Well, what if we moved 150 over a bit? That might work out. That 350 and then another 350. That is probably not quite right. Okay. We're halfway there. Let's just move this up, actually. That should match the 250. Or it should match the 400. Because that's our third bottom right point here. Hey, now we're cooking with gas. So we made a right triangle. I mean, perfect right angle. Totally didn't even mean to. Check this out. So our first point, 250, 400. 350 by 80. I'm not fine with how up high it is. Let's undo this right triangle. Let's go between 350 and 250. That's 300. There we go. So I think that's pretty good ground. We can consider. I think that hits most of the topic from the first chapter of this book. I will probably do a video on the challenge separately. They make a rainbow, which is pretty cool. Just a simple two-dimensional rainbow. We'll do that. We will maybe put a twist on it. Theirs is very typical up and over, like a wide rainbow. Maybe we'll do it vertically or do a double rainbow. But look out for that in the next video.